Hello everyone. Today we are going to introduce another new topic which is called sector area. After today's lesson you will see very similar formulas compared to the arc length formula. So let's get started. The first thing before we start introducing the formula, let's figure out what is a sector. So what does that mean when we see the word sector? Let's check a picture here. As you can see, sector is actually, you can see the part of the circle. So sometimes if you can think someone want to design a garden look like this kind of shape, or even the one we introduced before called shands. So the shape of this can make a lot of new design, and this part of the piece, part of the circle, we call sector. So it's formed by piece of the arc and also two radii. Three parts shaped one whole thing. This one will be sector. As you can see, this piece we still have the same word, central angle, and they look at it towards the intercept the arc here. So this kind of shape we call sector. So next we are going to introduce the formula. Before that, there is a quick review. Since we talk about the area here, so there's one thing I want to remind you. In this formula, we're going to use area of the circle. So some students already figure out the answer is pi r squared. So that's area of the circle. Pi again is a irrational number, r is our radius, and this time we are going to get squared. That's area of the circle. And you will see a lot in this type of the formula. So very similar to the arc length, we do have two methods. The first one, the sector area, again, we are going to use the piece of the whole circle is called a sector. How do we find the area? We are going to use the central angle here. So sector area equals central angle divided by 360 times pi r squared. Let's quickly check the structure of this formula. First is a ratio. So we find out the ratio of central angle towards the whole circle, and whatever the percentage, or we say ratio for this one, is we times the whole area of the circle, then that's part of this one. So that's the structure of that. And as you can see, it's very similar to the arc length. The only difference here, arc length we have circumference, but here we have area of the circle. However, one thing I want to remind you is central angle same as arc mirror. So we can also use arc mirror to replace this one. If we, for example, the question is given arc mirror is 60 degrees, then we can still replace it here. So this is same as central angle, same as arc mirror. So do not forget. So this, sometimes if we do see the arc mirror, we can definitely use that. So let's check the second method. Second method for here, some students already probably figure out it's very similar to the one we had before. It's actually using proportion. So let's check this. We have central angle over 360, meaning we figure out what is the ratio between central angle to the whole circle, then this ratio is same as this sector area compared to the whole circle. Very straightforward, right? And some students might wonder, if we have this kind of proportion or this kind of equation, how do we solve it? Some students already figured out the answer. We're going to use cross multiplication. In the second video, we're definitely going to practice more examples here. But the one thing I still want to remind you, do not forget central angle here, always same as the arc mirror. So if we do have arc mirror, we can still plug in here because they do have the same value. Okay, so that's all the formula I want to introduce for sector area. In second video, we are going to practice more examples. See you soon.